Being a software developer, you always aim to make experience of your users as better as possible. This implies easy-to-use, predictive user interface. When developing integrated software for SolidWorks, you want your application to look native and a part of SolidWorks. The best way to achieve it is to use Property Manager Pages as your user interface. Although it brings the best user experience, it comes with a cost. It is hard and time-consuming to design Property Manager page and bind it with your data model. It is even harder to maintain the property page if you need some revisions in your user interface. So quite often developers fall back to the simpler option and using Windows Presentation Foundation or Windows Forms instead of native Property Manager pages. Should you decide implementing Property Manager pages in your application, these are the typical steps you're going to follow. At first, you will design the data model, so this is the data your Property Manager page is going to serve. Then you go ahead and start designing your Property Manager page, adding controls, customizing those controls, etc. This usually involves quite a lot of coding. You might want to have some default parameters which should be read from your data model, so in this case you're going to fill the input parameters of your controls before opening the page based on the data in your data model instance. You will need to create Property Manager page handler so you can read data from your controls and write them back into your data model. You will need to write even more code to implement advanced behavior of your controls, such as state dependencies, cascading data sources, etc. When you need to revise your user interface and add or remove controls or modify their behavior, this usually involves multiple points of maintenance. It means that you usually need to modify the code in multiple different places to make your model work intact. Let's take a look at this challenge from different perspectives. The end goal of Property Manager page or any other user interface is to provide the data which was entered by the user. Let's consider the following example. As part of our application, we'll need to take 4 inputs from the user, one of the string type. Let's say that could be a path to the file, a file name, etc. Second property is an integer type. For example, it could be something like number of copies. The third property is of Boolean type. For example, something like do you want to override the file. The last property is a selection object, which could be something like a component which user selects from the design tree. To collect this input, we can define the following data structure. Let's now think how user interface, in our case Property Manager page, would look like. We will need to have a text box to serve our string property. We will need to have a number box to serve our integer property. For our Boolean property we can add CheckBox, and for selection we can use SelectionBox available for Property Manager pages in SolidWorks. Let's take a look at another example. Let's say that our application is going to change the color of selected bodies. So we're going to define the enumeration of available colors, red, green and blue. We're going to allow user to enter opacity, which is from 0 to 1, so it is a double type. And finally we will allow user to select multiple bodies. So we define that property as a list. In order to collect that input, we're going to design Property Manager page which looks like that. We have a drop down with available colors, we have a number box to collect our opacity value, and we have a list box which allows to do a multi-selection to collect our bodies. And majority of your user input would operate with the simple types such as string, integer, Boolean, enumeration or selections. And if you look into the data model and the corresponding Property Manager page, you can see it is pretty predictive how your user interface should look like based on your data model. Although it is technically possible to serve your Boolean property as a text box, it would be counterintuitive, as your user would expect checkbox for that property. So assuming there is a direct correlation between properties in your data model and the corresponding user interface controls, the question is, can we avoid using those intermediate steps and go directly from your data model to Property Manager page? The answer is yes, and this is how xcad.net framework works. Hello, this is Artem from Xarial, and in this video tutorial I'm going to teach you how to write a modern responsive Property Manager pages in a matter of minutes using xcad.net framework. xcad.net is a free and open source framework which revolutionizes the way you develop applications for CAD. It is fully adapted to .NET and enables fundamentally different ways of working with your user interface, documents, macro features, properties, metadata, and much more in your CAD. I will show how this framework can take your data model and automatically build the best suited property manager page for that. Furthermore, it will automatically bind data in two directions, so you can supply default values for your property manager page and collect inputs from your user directly in your data model without any additional steps. We are going to learn how to create property manager page and customize its look and feel, how to create tabs in property manager page, how to create groups in property manager page, how to create simple controls such as TextBox, NumberBox, drop-down lists, CheckBox, buttons, toggle buttons. We will learn how to collect selection input from your users. This includes an advanced customization of a filtering if you want to only allow specific entity or entities to be selected in your selection box. We will learn different ways of specifying data source for your drop-downs, ListBox and OptionBox, including the cascading and dependency lists. I will also show how you can enable even more customization by adding the custom Windows Forms or WPF controls directly to your Windows form. We will learn how to create a responsive interface which reacts to different changes and updates your data model accordingly. Let's start by creating a new project in Microsoft Visual Studio. We're going to use class library in .NET Framework. Let's specify the project name and click Create. Now we need to install references to xcad.net. xcad.net is hosted in NuGet, so we can simply go to NuGet Package Manager in our project, search for xcad, and install Xarial xcad SOLIDWORKS package. README files helps us start, but I already have some predefined code, so I'm just going to paste it into my class. So this code will create a button in our toolbar and menu, and when button is clicked, we're going to display our property manager page. So let me just import a few namespaces to make the project compilable. Now I can rename the name of my class file to match the class name. We're going to start by creating a simple property manager page without controls. For that, I'm going to define the data model for our property manager page. So let me create a page subfolder and create a data model. This data model will contain all the properties I want to be sorted by my property manager page, and using xcad.net is going to also drive the user interface of my property manager page. I can create a different class for my data handler, but in this case I'm going to embed it with my data model. So I need to inherit my class from SW property manager page handler and mark this class as ComVisible. Now let me create two variables, one which is going to hold our data model and another one which is going to hold the pointer of our property manager page. So first one is going to be called m_data, and it's going to be an instance of our data model. The second field is of generic type IX property page, where the generic parameter is our data model. I will declare this field and name it m_page. I will create an instance of my data model from within the onConnect functions, and I'm also going to use createPage API to create the corresponding property manager page. As I'm going to reuse the instance of this page, it is sufficient to create it within the onConnect function. Depending on the requirements, you may need to create it another time, for example when you click a button on the toolbar or menu. Property manager page will raise few events, so let me subscribe to closed event. This is going to be raised when our property manager page is closed. So let me put a breakpoint here. Finally, let me go to project properties and specify the path to SOLIDWORKS executable in the start external program option. This will simplify the debugging process. As a last step, I'm going to show my property manager page when corresponding command is clicked on a toolbar. To do that, I need to call show function of property manager page and pass the data model as a parameter. Now we can click F5 and run our project. When add-in loads, onConnect function is called, and this is where our property manager page and data model are initialized. We can now create new part and test the functionality. So let's click the button in the menu to open our property manager page. As you can see, our handler is hit, and we can call the show command to display property manager page. So it is empty for now, but when I click green tick, you can see that our handler is called, and you can inspect the reason of closing. Let's now close SOLIDWORKS and continue with our tutorial. I will assign a custom icon, title and description for my Property Manager page. So first I'm just going to import image into my resources of a project. You can use any image, transparency is supported, and image could be of any size and ratio. In order to customize the look of my Property Manager page, I simply need to decorate my data model class with some attributes. And I'm going to use title, description, and icon attributes. So let me import namespaces. And you can see that for icon, I used my image from the resource. Now I'm going to implement some logic of my Property Manager page. I'm going to add a checkbox which is going to drive whether my Property Manager page can be closed or not. If this checkbox is checked, my Property Manager page should not close when user clicks green tick. Furthermore, I want to display the error message, and this error message is going to be read from a text box on the same Property Manager page. This is going to be managed by two properties in my data model. First is disable closing property of a Boolean type, which corresponds to checkbox. Another one is close error message property of a string type, which corresponds to textbox. In order to disable closing of our Property Manager page, we need to validate the condition while Property Manager page is being closed. So we can do it within the closing event. And similarly to all user interface controls in .NET Framework, argument will be passed to the handler of closing event, where you can validate the condition, and the condition is met, we can set the cancel property to true and specify the error message. So as you can see, if our disable closing is true, we're going to cancel closing of our Property Manager page. Let's test it. We'll create new part file, run open page command, and validate the result. We can now match our Property Manager page with our data model. Title of the Property Manager page corresponds to the value in the title attribute. Similarly, message of the Property Manager page is a value in our description attribute. And finally, icon of the Property Manager page matches the value of the icon attribute. Checkbox has been created to serve our Boolean property, and TextBox has been created to serve our string property. Furthermore, our data model has been automatically bound bidirectionally to our control values. Let's click green tick and see the result. So you can see we can check the value of our property. As our checkbox is not checked, we will not going to meet that condition. Now let's open Property Manager page again and check disable closing checkbox and specify some error message. So you can see our data model has been updated. So we can specify the cancel of our argument, and as you can see, our Property Manager page is not closed and error message is displayed to the user. Now I want to create another class in my project which is going to hold some more properties in my data model. So let's call this class Simple Controls Group. I'm just going to paste my code in here, and also going to import few namespaces. And I'm also going to declare enumeration used in this class. So as you can see, this class contains all sorts of different properties: string, integer, double, enumeration, action delegate, ixface, image. I expect xcad.net framework to create the corresponding Property Manager page to serve those properties, and I will show you how it looks in a minute. But before that, I need to connect this class to my existing data model. So I'm just going to create a variable within my data model class. I'm going to call it Simple Controls. So as you see, it is a variable of a complex type. Finally, let me set some default values on a couple of variables in this data model. So I expect those values to be automatically read and displayed in my Property Manager page when it is opened. Let's click F5 and start debugging process. Similarly to previous steps, we can just create or open existing part and run open page command. As you can see, more controls are available in our Property Manager page. Let's inspect it and match it to our data model. The additional class we defined in our data model has been rendered as a group in Property Manager page. As before, string property resulted into the text box, but now as you can see the default value matches the default value we assigned from our data model. NumberBox is created to serve our integer property, and similar to before, the default value we assigned in data model has been assigned to our control. Another NumberBox is created for the property of double type. Dropdown has been created for the enumeration, and the fields of the enumeration match items in our dropdown. As before, CheckBox is created for the Boolean property. The property of type action, which is a delegate, is served as a button. And the handler of this delegate is a function which is going to be called when the button is clicked. IXFace is a type from the xcad framework and corresponds to the face. So when you have a property of this type, SelectionBox will be created. In this case, it is clear that you're going to select face, so framework automatically assigns the corresponding icon to SelectionBox control. So now we can activate that control and select face from our graphics tree. So you can see the selection appears in our SelectionBox control. Finally, the property of image types has been rendered as PictureBox, where the instance of an image has been displayed in this PictureBox. We can now modify some values. Let's select different option in the ComboBox, assign some numeric values, and click green tick to validate the values in our data model. Now I can inspect values of my m_data variable, which corresponds to data model, and you can see CheckBox, ComboBox, NumberBoxes, our field, including the SelectionBox, is set to the instance of the selected face. Previous section of the video demonstrated how the controls could be automatically created based on the property types of your data model. But sometimes it is required to add some further customizations to your control. xcad.net frameworks provide a very simple mechanism of customization of your controls. This can be done by decorating your properties and classes with corresponding attributes. We have already briefly touched that when we modified the look of our Property Manager page. You can apply similar techniques to your controls. Let's create a new class which will correspond to new group in Property Manager page and call it Controls Customization Group. I'm going to paste my code with data model and we're going to inspect it in more details in the next step. As you already noticed, properties of a custom type will be rendered as groups in our Property Manager page. There is another type of container available in user interface, and this is a tab. So let me show you how you can create tabs in your Property Manager page. So let me create a new class and call it Controls tab. Now, instead of defining the properties of customization group in my main data model, I'm going to define this in the Controls tab. And finally, I'm going to decorate this class with tab attribute to tell the framework that this class should be rendered as a tab. I will define the property of my tab in my main data model. I can further customize it and add some attributes. So let's add the title attribute to name our tab. We can now start SOLIDWORKS and inspect results. We can now open the model and open our Property Manager page. As you can see, now our group is rendered within the tab, and it is called tab 1 as we have specified in our data model. You can also see multiple controls with different customizations. So first, TextBox has a green background and yellow foreground. Second, NumberBox control has a standard icon of diameter assigned to it. Next, TextBox has a custom height and also supports multi-line, and there is no border around the control. Next, NumberBox has a thumb wheel which you can scroll to change the value, and it's also set to hold length units. Thus you can see the unit next to the value in the NumberBox. ComboBox is displayed now as an editable text instead of the drop-down list. Furthermore, you can see that items of the ComboBox can also be customized by providing the corresponding attributes on the fields of the enumeration. ListBox displays the sorted values regardless of the order they are specified. I will provide more details about ListBox in the next section of the tutorial. The same picture is rendered as in previous section, but now it has a custom size. Action delegate will be rendered as a button by default, but in this case we have customized it to render it as a bitmap button and assigned one of the standard icons to that button. In this case it is reverse direction icon. Similarly, Boolean property will be rendered as a checkbox unless we assign bitmap button attribute to that, so now it is rendered as a toggle bitmap button with a custom icon. One of the main advantages of Property Manager Pages compared to Windows Forms is an ability to capture selections. In this section of the video I will demonstrate how to create, customize and enable custom behavior for selection boxes in Property Manager Pages. I will be demonstrating more advanced controls in the next sections of the video, so I'm just going to place them in a new tab and call it Advanced Controls tab. It is also possible to assign the custom icon to the tab in the exact same way you do this for controls. Now I need to create a property for my tab in my main model, and I also want to know that you can decorate that property with a tab attribute to indicate that this should be rendered as a tab instead of adding the attribute to the class. My selection boxes are going to be placed in the new group called Advanced Selection Box Group. For now I'm just going to add 3 selection boxes and going to demonstrate how they work in the next step. Let's define the property for this group in our tab. Let's import namespace, and now we can run our SOLIDWORKS and debug this functionality. Let's open the same model and activate our Property Manager page. So as you can see, we now have 2 tabs and second tab has a custom icon. Let's now explore the customizations of those selection boxes. First selection box has a custom icon assigned to it. The property is defined as IXL object type, which means that it could potentially hold any selectable object in SOLIDWORKS. In this case, we limit our selection to 3 types of entities: edges, faces, and vertices. And as you can see, I can select all of those entities into my selection box. And note that the selection color is pink, as we have set the selection color to be a secondary color from our color scheme in SOLIDWORKS settings. Second property is declared as a list of IXEdge objects. This means that you can only select edges into this selection box, and furthermore, you can select multiple edges. Last property is declared as IXPlanar face, which means only planar face could be selected. We can now click green tick and inspect our data model. So I expect all of these selected entities to be assigned to the corresponding properties in our data model. Let's expand Advanced Selection Box, and as you can see, we have a selection object in our first element, and we have a planar face and 4 edges in our last property. In some cases, it might be required to apply additional logic when filtering the object to be selected into the selection box. Let's say that we will only want to select red planar faces into our last selection box. To do that, we should create a special service which implements iSelection custom filter interface and implement our logic in there. We then need to specify that service to be used as a custom filter for our selection box. So we can use SelectionBox options attribute and specify the type of our service as a custom filter type parameter. Now filter function will be called every time the entity is about to be selected, and you can implement any custom logic to allow or disallow the entity to be selected. This model has 2 faces of red color with different shades, so let me open Property Manager page, and firstly I want to select face which is not red and see how the code will behave. So I'm setting this planar face, I'm extracting the color, and there is no color assigned to this face, so I'm returning false, which means that I do not allow selecting this entity. This face does have a color, and the red component of the color is 255, which means it is a red face, so I allow a selection. Please note that I can also change a text appeared of my entity. So in this case, I'm calling it red planar face and specify the RGB value directly in my selection box. It is also possible to create Checkable GroupBox. So let me create new class and call it toggle group. I'm just going to paste my code in here. Let's quickly explore this code. As you can see, our toggle group class is decorated with Checkable GroupBox attribute, and the first parameter of this attribute is toggle group is checked. We also have isChecked boolean property, which is decorated with metadata attribute, and the first parameter is the same toggle group is checked. This is a mechanism xcad.net is using to bind two properties. We effectively telling the framework to bind the toggle state of our group into the isChecked property within that group. We can specify any tag of any type in order to make this binding, and it is important that this property could be located anywhere in data model. It does not necessarily need to be in the same class as our toggle group. Please note that the properties decorated with metadata attribute are special properties, and controls will not be created for those properties. For example, in this case we will only have one text box within the group. Let's declare the property for this group within our controls tab. There is also another attribute you can use if you want to exclude certain properties to be rendered as controls. So let's create a new string property called systemText and decorate it with exclude control attribute. So control will not be created for that property. We can now start SOLIDWORKS and explore this new functionality. So first step, I just want to create a button on my toolbar so it will be easier for me to access Property Manager page. So you can see now I can just simply click that command and it opens Property Manager page. As you can see, there is a new group with a checkbox which we can check and uncheck. Let's explore how our data model behave. So if the checkbox is checked, you can see that our isChecked property of the toggle group class is set to true. In this section of the video, I will demonstrate how to customize ListBox, OptionBox and ComboBox controls, how to define custom data source, and how to enable dependencies between the controls. Let's create a new group which is going to host our controls. We can call these groups item source controls group. Let me paste the code in here and import required namespaces. This group contains different combo boxes, list boxes, and option boxes. Let's define the property which is going to host our group and start SOLIDWORKS to explore this code. Let's activate Advanced Controls tab, and here we can find our group. Enumeration is used as a data source of items for this combo box. So this is similar to what we have discovered in previous steps. Item source of the second combo box depends on the selected item in the first combo box. This combo box behaves as a cascading list. As you can see, second combo box is decorated with the combo box attribute where the first parameter provides a custom items provider. Second parameter specifies the optional dependency. So in my case, it's going to be dependent on the control called myComboBox. In order to specify the control name, we need to use control tag attribute. So this is very similar to toggle group with the metadata attribute. Let's now add breakpoint in our code and see exactly how that works. We will put the breakpoint in provide items method, and now we can change the value in our source combo box. As you can see, this method is called. I can extract the current value for my dependency and return the array of strings for my new combo box. So as you can see, now the array of strings is set as a data source for this combo box. By default, the property of enumeration type will be rendered as ComboBox, but you can override this behavior. And you can represent enumeration as ListBox by decorating the property with ListBox attribute, or by group of options by decorating this property with OptionBox attribute. In some cases, it might be required to load items data source from an existing property in your data model. You can do this by creating an array and marking that property with a metadata attribute. Then it can be bound to your ComboBox by specifying the item source and linking that to the metadata by name. In our case, item source property contains 4 items which are initialized in the constructor. And those items are linked to the ComboBox, so you can see those items are available in the dropdown. In a similar way, we can create item source of the custom types. And this could be rendered as ComboBox, ListBox or OptionBox. Next property is defined as list of custom items. And because we have a ListBox attribute assigned to it, this property is going to be rendered as ListBox. Because it is of list type, it's going to support multi-selection. Finally, you can specify a simple list of values to be used as item source. In this case, I have defined items of a ListBox from 1 through to 5. In some cases, available controls and customization options might not be enough to fulfill your requirements. In this case, you might want to fall back to more sophisticated options such as creating the control in Windows Forms or Windows Presentation Foundation. xcad.net supports both of those scenarios. So let me demonstrate you how you can host a custom Windows Forms or WPF control in your Property Manager page. I will start by creating new Windows Form controls and also by creating new WPF user control. Let me add some simple user interface to differentiate those controls in the Property Manager page. I will add blue background for my Windows Forms control, and I'm just going to create a yellow background for my WPF control. WPF control is going to be bound to view model, which has a property called message, which is going to be displayed as a text block. I will define some additional functionality for my Windows Forms control, and I would allow user to double click onto the label, and this is going to change my data model. In order to bound Windows Forms control to my data model, I need to implement IX custom control interface. This interface defines read-write property value and value changed event. Value property will be bound to the property in your data model, while value changed event allows to implement responsive user interface. So whenever property is changed, you can notify your data model and update it accordingly. In this demo, I will update the value with a random GUID when user double clicks on the label, and I will raise an event to notify my model about the data change. Let me go ahead and create new custom controls group where I'm going to host WPF and Windows Forms control. WinForms control property will be of type string and will be bound to our Windows Forms control. And this string will be displayed in our label. As you can see, custom control attribute is used to specify which control is bound to that property. You need to pass the type of the control as the first parameter of this attribute. WPF control VM is a view model for my WPF control, and as you can see, WPF control property is defined with this type. The value will be assigned as data context to my WPF control, so I can use the binding to display this in the text block. We can now create a property in our Advanced Controls tab to display this group in Property Manager page. Let's start the debugging process. After SOLIDWORKS has launched, we can create or open new part and open our Property Manager page. Let's activate Advanced Controls tab, scroll down, and you can see our group with 2 custom controls rendered. Let's double click on our label and you can see that the value is dynamically updated. Let's click green tick and inspect our data model. And as you can see, the property has been successfully updated with our random GUID. There may be occasions when it is required to update the values of your controls from within data model itself. For example, it is required to do some calculations, so you click the button, do calculations and update your controls. Let's try to emulate this scenario. I'm going to create a new reactive controls group, and here I have a checkbox, textbox and a button, and the values of textbox and checkbox are updated when the button is clicked. In particular, textbox is assigned with new random GUID and checkbox value is reverted. Let's create a new tab and call it behavior tab. I'm just going to host that group in that tab. As this is a new tab, I need to make sure that I add it to my main data model. So let me create a new property here and call it behavior. Now we can run and see the result. Let's open our sample model and open Property Manager page. We need to navigate into the Behavior tab and click Change Values button. I have a breakpoint, so I'm going to inspect the code. So as you can see, my properties have been successfully updated. But when I look into the user interface, you can see no controls have been updated. This happens because our Property Manager page doesn't know that the data model has been updated, and so the control should be updated as well. If you have been developing the application with Windows Presentation Foundation, you'll know that it runs into similar scenario. And this issue is fixed by implementing Notify Property Changed pattern. xcad.net supports the same mechanism, so in order to fix that problem, we need to implement iNotify Property Changed interface in our data model and invoke Property Changed event whenever our property value has been updated. Framework will process this event and update the controls correspondingly. Let's now repeat the steps and see how it works. I'm going to activate Behavior tab, click Change Values button, and as you can see, the value in a text box is immediately updated and value of the toggle is reverted. Rich user interface might require changing the state of the controls based on the values of other controls. For example, checking the checkbox will disable another control, or selecting the options from the drop-down will hide another control. I will start by creating a new group and I will call it Dependency Controls Group. I'm going to have 4 controls in this group. The first control is a checkbox, and this checkbox drives the enable-disable state of the following text box. There will be another combo box with 2 values, visible and hidden, and depending on the value, the last text box in this group will be hidden or visible. I will be using dependent on attribute to define the dependency between controls. First parameter of this attribute defines the service which is going to resolve our dependency. This service implements iDependencyHandler attribute. The second and consecutive parameters could define the control tags of the dependent controls. We can access controls and their respective values from within the dependency handler, and we can also implement the custom logic to update the state of our input control. In first dependency handler, we're going to extract the value of checkbox, and this will drive the enable state of our text box. In the second dependency handler, we're going to extract the value of ComboBox, and this is going to be enumeration, and if the value of that enumeration equals to visible, we're going to display our text box, otherwise we're going to hide it. Let's do a final preparation and declare that group in our tab. Now we can start SOLIDWORKS and test our functionality. Dependency handler will be called every time the value of our dependent controls have changed. When we open property page or change the value of dependent controls, the handler will be called. So you can see the handler is called when we start property manager page, so we can calculate the value and set the enabled property of our source control. So in this case it's going to be disabled. We can now change values in our property manager page. By checking the enable next, we are going to enable the text box which follows that checkbox. So let me firstly add our variables to watch so you can see how the logic works. So you can see that checkbox is now updated. If you select hidden from the drop down, it's going to hide the following text box. So as you can see, the value of our enumeration is hidden, thus is going to hide the text box after that. So as you can see, changing the drop-down values or checkbox values immediately changes the state of other dependent controls. All the examples previously demonstrated in these tutorials require you to have a class at the compile time, which means you cannot dynamically create controls at runtime. Although in majority of cases you will not need to create your controls at runtimes, there are, however, could be situations where it could be quite handy. And in this section in the video I'm going to demonstrate how you can create controls dynamically at runtime using xcad.net. I will start by creating a new group and I'm going to call it Dynamic Controls Group. Let me paste code here. So this group contains the function called create dynamic controls, and this is the function I need to pass to my property manager page creation method. Let's do that. I need to modify create page call. So firstly, I also need to create an instance of my group so I can pass the delegate rather than a null. So let me create firstly an instance of control tab and also an instance of the group within that tab. Now I will not have a null reference exception, so I can simply pass the method from my group into the create page API. So mdata, controls tab, dynamic controls group, create dynamic controls. So this function is going to be called every time property manager page will need to resolve dynamic controls. This function should return controls descriptor, and they're going to be parsed by a framework and the controls will be created. So you can see our tag is passed and I'm just returning two controls from my method. Data type property of my control descriptor defines the type of the control. So if I have specified string, it's going to create TextBox control. In case of a double, it's going to create NumberBox control. Attributes property allows me to define the custom attributes, just like you can decorate your properties. So in this case, my text box is going to have additional background and foreground, and my number box is not going to have any additional options. The property which is bound to dynamic controls is going to be considered as a context, and is going to be passed to the getValue and setValue methods of our control descriptor. So you can see that our dictionary passed here. For now it's empty. So in my example, I'm just going to write the values of the controls into the context dictionary. So if I activate my property manager page and start typing the values into my dynamic controls, you can see that it first calls getValue and then it calls setValue function. In setValue function, I simply write that value into the dictionary. I can also modify the value of my number box, and I'm also going to call similar handlers. So now you can see my dictionary is filled with two values from my property manager page. Let's go ahead and modify these values and click green tick. And if I'm going to expect my data model, you will see that our dictionary is now filled with those values from the property manager page. Source code for this demo in C# and VB.NET is available for download from GitHub. Please find the link in the description of this video. You can find more information about xcad framework by navigating to xcad.net website. For any inquiries, please contact us via email xcad@xerial.com. Thank you for watching this video.